Hello, in this video I'm going to show you how to draw points on your WebGL application. So let's just get straight to it. So make sure you watch the video where we set up literally a very simple WebGL project. We'll be adding to it and making it better and better. So first of all, what we need to do, because we're just drawing a single point, we need to have an array, and we're going to call these vertices, and these we're going to have 3 vertices. Each vertex will refer to a single point. 0.0, 0.0, and 0.0. And you can pick whatever number you want. I will explain what these numbers do once we wrote the code and run it. I've chosen these numbers specifically, but that's just for demonstration purposes. So I'm going to do 3 points in total. And now what we need to do is create an empty buffer object which will be used to store the vertex buffer. So we just do var vertex buffer equals GL vertex buffer GL dot create buffer. And now what I'll do underscore just because I've got some code that I'm referring to and it'll be just easier that way. Okay, so next what we want to do is actually bind the array buffer to it. So to bind it, you do gl dot bind buffer gl dot array underscore buffer vertex buffer. Then you have to pass the vertex data to the buffer. So gl dot buffer data, and first of all you specify what you're dealing with, and it's going to be the gl dot array buffer. Then you need to create a new float 32-bit array, and this is going to be comprised of the vertices. And next we just need to specify how we're going to draw it. It's going to be a static drawing, so gl.static underscore draw. Okay, so next we just need to unbind the buffer once this is done. So let me scroll down a bit. gl.bind buffer. To do that, you bind it to null. So the buffer that you all want to bind, so gl.array buffer and put comma null. So this just says this is assigned to this. Likewise, this is assigned to this. No equals, you are passing it into a method. Now we need to set up the shaders. So I'm going to do var vert code. So this is the vertex shader now. And what I'm going to do is put quotation marks here. And first of all, first line, I'm going to put attribute like so, vec3 coordinates. So creating a vector-free coordinates variable. And now we're going to put plus. This is just so we can do it in multi-line, just so it's easy to visualize and see when we're reading the code. And first of all, we need to put a void main. So this is just within the shader itself. Eventually you can separate this out into separate files, but for this we can just keep it all in the same file for now. And less than, again we need to do plus for every new line. Indent it just so it's easy to visualize, but that's not a hardcore requirement. gl underscore position equals vec4 coordinates 1.0 semicolon, and then we just do gl underscore point size equals 10. So this is the size of the point. The bigger the number, the bigger the point. Simple as that. And semicolon on the inside. Plus, finally, all we need now is to close the curly brace. This specifies the position, which will be based on the coordinates, which is going to be based on the vertices array that we've created, but we haven't quite linked that. That's going to be passed in, which we'll be doing very shortly. Next, what we need to do is create the vertex shader object. So var vert shader equals gl dot create shader, and we just specify the shader that we're creating. So gl dot vertex underscore shader, and then we need to attach the source code from the vertex shader. So we do gl dot shader source vert shader and vert code like so, semicolon, and now we need to compile this shader. To do that, we do gl.compile shader vert shader, which is just what we created above, right here, and semicolon. Next, what we need is the fragment shader. So the vertex shader, if you don't know what that does, that's essentially the geometry of our shape. In this case, it's just a point or multiple points, and that's it. That's all it does. It's just essentially the way it looks. The fragment shader is all about the color of it. So the way it, you know, did I say the way it looks? No, I mean like the shape of it, the size, that sort of. So the fragment shader is all about the color itself. That could be a color from a texture, and that is more complex, something I'm going to cover in a separate video, but it is still essentially a color that is being displayed. It might be multiple colors, and the colors might be interpolated over several faces, but ultimately it is still a color. So now that we've compiled the vertex shader, we need to do something pretty similar for the frag shader. So we do var frag code, which is short for fragment shader or fragment code, and this is going to be equal to void main. Still need the pluses. Open curly brace, next the plus, and we're going to put gl underscore frag color equals vec for 0.0, 0.0, 0.0, and 0.1. So we are hard coding the color value in, and it is going to be black. So this is all off, and it is black with some opacity as well. So feel free to, you know, change that up, experiment. And next, what we're going to do is close the curly brace, semicolon. So that's both the shaders done. Now we need to create the shader object for the fragment shader. So to do that, we scroll down a bit. We do var frag shader equals gl.create shader, and we just specify what we're creating, so which is the gl dot fragment, all uppercase, sorry, fragment underscore shader, and now we just need to attach the source code, you know, for the fragment shader. So to do that, we do gl dot shader source frag shader frag code semicolon. Now we just need to actually compile the shader. So gl.compile shader frag shader semicolon. So now what we need to do is create a shader program for var, because otherwise we can't use these shaders without the shader program, equals gl.create program. So the actual names of the functions are very self-explanatory, which is great. Now we need to attach the shaders. To do that, we do gl.attach shader. We just do one by one. We do the specify the program that we're using to attach, so shader program that we just created, and now vert shader for the vertex shader, and I'm going to copy and paste this, and the only change I'll make is we are now attaching the fragment shader. Okay, so now we need to link the programs. To link it, what we do is gl.link program shader program. And now what we need to do is actually use the combined shader and program. So it's the program, which is just essentially says what it's going to execute, and the shaders that we created. To do that, we do gl.use program shader program. So now we need to bind the vertex buffer object. So the buffers are used in memory to store data about what we are drawing, like the shape, the points, the color, everything. So to do that, we do gl bind buffer gl.array underscore buffer. Make sure you get the case sensitive, the case uppercase and lowercase right, because it is case sensitive. Vertex buffer, what we already created above. And now what we need to do is actually get the attribute location. So we just do var and create some coordinates. So chord equals gl. Let me scroll down a bit. Dot get attrib, so which is short for attribute location. So we specify the shader program, and we specify what we're doing. So coordinates. So remember this. That's what that refers to. So make sure it is exactly the same. So what this is saying, we are going to, pass in some sort of data. So the vertex is expecting a vec3 locally called coordinates, and it's used here. Otherwise, how would we get it into it like so? So that's what it is expecting. There we go. Now what we want to do is actually point the attribute to the vertex buffer object that is currently loaded. To do that, we do gl.vertex attrib pointer chord free gl.float false 000. So specifying what type of data it is floats, as you can see from here, and we're specifying how many there are. So for each free, that's one set of coordinates, and the chord is just what we're just using right here. We're almost done now. We just need to enable this attribute, and then we need to actually just draw it. So we do gl.enable vertex my disk space is almost full. Let me okay, so that should help empty in the bin. Okay, so enable vertex attrib array chord semicolon. Make sure this is still recording. Yes, it is, and we're empty, so we should be all good to go now. I'll make sure that I've got more space next time. Okay, so now that we've enabled the attribute, what we need to do in between clearing the color and clearing the color buffer, what we need to do is enable depth test. gl.enable, this allows for 3D. We'll be using that later, but it's good to have that enabled now. gl.depth underscore test. Okay, so now what we are going to do is set the viewport. So gl.viewport, it's going to be 0, 0, usually starts at 0, 0. If you want it to start differently, you can do, but that's usually the way. Canvas.width. Canvas is what we created earlier in a different video, so feel free to recap on that. Canvas.height. And finally, we draw the triangle by doing gl.draw arrays, and we do gl.points. So it's a bunch of points, 0, 3. So the 0 refers to where we are starting. So 0 in this case will be this one, 1, 2. 3 is not the end one, but how many we want to draw. So in this case, start at 0. This will be 1, 2, and 3, but it starts at 0. Okay, so we can save that and now run. So make sure we got no errors. Get no errors. We got some warnings. Line 64. Make sure that's all good. Line 64. So what's it saying about the use program? It's probably fine. It's just a bunch of warnings. We might think we're not seeing anything. And that is because when we drew the point, we made it black. The background black. So it's hard to see. So let's actually make the background red. So 1.0, so RGB. Keep everything else as 0 and we'll keep this as 1. Save that. Rerun it. Okay, so the points aren't appearing. Like one should be there, one in the corner, one over here. That means something has gone wrong here. Possibly could be to do with one of these. It might not be, but let's have a look. So we got vertices. I don't think having a comma there makes a difference. Let's have a quick, look over and make sure we got everything. So Vertex Buffer, gl.create buffer, I'm happy with that. Then we bind the buffer to the array buffer, Vertex Buffer. Then we pass the vertex data, array buffer, new float32 array, vertices, GL static draw. Okay, so far so good. GL bind buffer, GL underscore array buffer, comma null, vertex code, attribute, vec 3/4. A lot of the time there could be errors in here, and something small, it could cause a big error. And we won't actually, notice it won't throw an error specifically. Make sure having a space there doesn't make a difference. I know sometimes you do put that in. Vec4 coordinates, comma 1.0, semicolon. There is not a plus here, and there is not a plus here as well. Let me have a look at that. Okay, so all those errors have disappeared now, but still nothing is appearing. So let's have a look at this. That's interesting. Empty cache and hard reload. That error is to do with the favicon. Okay, they've appeared there. Should be height. There we go. There they have. So I had a few errors. One, forgot to put a thing there. And you know what? I can't 100% remember what it is. So I'm going to Google it. JavaScript strict mode. So I'm going to whack it into strict mode. I think it's use strict. Use strict. Okay, so if I run this now, and if I go back and I'll just do that error of the T, probably that didn't throw an error. Strange. I'll have to have a look at it for the debug inside of it. Let's get rid of that then. Okay, so yeah, I had that problem and I forgot to put the pluses, so otherwise it wasn't reading it properly because we was on multiple lines. So what do we have? Let me rerun it. We got these 3 points. We got 2 here and 1 in the corner. So this one is this one right here. So if you just specify 0, 0, 0, the last 0 is the Z index, going in and out. We're not doing 3D in this video quite yet. We'll be doing that later in the series, so we can ignore this, the last coordinate. And another thing to bear in mind, you can actually put all this on one line. and as you can see, it still works fine. The reason we spread it out, because this way, we don't know where it starts, we don't know where it ends easily. This way we know this is 1 set of coordinates, this is 2, and this is 3. It's just easier for us to see. Okay, so this is x, this is y, and yeah, it starts at 0, 0, which is the center. If you do a positive value in the x-axis, it moves right. Negative value in the x-axis moves left. A positive value in the y-axis moves up, and a negative value in the y-axis moves down. Okay, so what's all this about 1.0, 0.5, where when we go into the index HTML, we got a width and height of 640 by 480. So what these are normalized coordinates. Normalized coordinates range from -1 to 1. So what that means is 0 will be center, -1, let's say if it's the x-axis, will be all the way on the left. That will be 0, and that will be 1. 0.5 will be half, or like 3/4 of the way along, halfway between the middle and the right, and -0.5 will be there. So when we did 0.5, it went there. Then when we did -0.5, it went down to there. When we did 1.0, 1.0, it went positively that way and then up to there. So that's just something to bear in mind. I'm going to have a separate video covering normalized coordinates and device coordinates in more depth. So feel free to check that video out, and I'll show you how to get around. It's not really an issue, it's just a different way of doing things that may seem counterintuitive if this is the first time you are encountering it. But it just ensures all the time that if you want it to be in the top right, for example, you just put 1.0, 1.0, it's always in the top right. If you want it to be halfway along, or technically 3/4 of the way along, you'll be 0.5. So that's it. If you have any questions, feel free to pop me a message, and as usual, I look forward to seeing you in the next video.